everyone, this is Shena and this topic is for IT Prof Elective 3 and my topic is all about classification.
So, ano nga ba ang classification? So, sabi dito, a classification is a very important area of supervised machine learning and a large number of important machine learning fall within this area. And there are many classification methods and logistic regression is one of them. Supervised machine learning algorithms define models that caption relationships among data. It tries to predict which class or category some entity belongs to based on its features. So, kapag sinabi natin classification, ito yung process of categorizing a given set of data into classes. So, pwede siyang i-perform on both structured or unstructured data, and the process starts with predicting the class of given data points. So, the classes are often referred as target, label, or categories. So, example nito is, sa isang company, maari mong i-analyze ang mga employee of some company and try to establish a dependence on the features or variables such as the level of education, number of years in a current position, pwede ring age, salary, odds for being promoted, and marami pang iba. So, ang set ng data na nauugnay sa isang employee ay isang observation o observation.
As you can see here, classification algorithm is a supervised learning technique that is used to identify the category of new observations on the basis of training data. So, sa classification daw, a program learns from the given data set or observations and then classifies new observation into a number of classes or groups such as yes or no, 0 or 1, spam or not spam, cat or dog, and many more. And classes can be called as target, labels, or categories gaya nga ng sabi ko kanina. So, sa classification algorithm, a discrete output function y is mapped to input variable x. So, ganito, y equals f x where y equals categorical output. And the main goal of the classification algorithm is to identify the category of a given dataset, and these algorithms are mainly used to predict the output for the categorical data. So, ang example daw dito ay yung email spam detector.
The features or variables can take one of two forms. Number one is the independent variables and the second one is the dependent variables. So, kapag sinabi nating independent variables, it is also called inputs or predictors. And it don't depend on other features of interest, or at least you assume so for purpose of the analysis. Kapag sinabi naman nating dependent variables, tinatawag din siyang outputs or responses. It depend on the independent variables. Kagaya nga ng example ko kanina sa isang kampanya. So, where you're analyzing employees. So, you might presume the level of education, time in a current position, and age as being mutually independent and consider them as the inputs. So, the salary in the ads for promotion could be the outputs that depend on the inputs. The nature of the dependent variables differentiates regression and classification problems. Regression problems have continuous and usually unbounded outputs. An example is when you're estimating the salary as a function of experience and education level. On the other hand, classification problems have discrete and finite outputs called classes or categories. For example, predicting if an employee is going to be promoted or not, whether true or false, is a classification problem. And there are two main types of classification problems. First, we have the binary or binomial classification, and the second one is the multi-class or multinomial classification. So, kapag sinabi nating binary or binomial classification, it is a classification condition with two outcomes which are either true or false, and exactly two classes to choose between, usually 0 and 1, and true or false, and positive and negative. Kapag sinabi naman nating multi-class or multinomial classification, the classification with more than two classes, here each sample is assigned to one and only level. So, magkaiba yung binary sa multi-class kasi yung binary is kumbaga nagka-classify siya ng condition with two outcomes different from the multi-class. And if there's only one input variable, then it's usually denoted with x. For more than one input, you'll commonly see the vector notation x equals x sub 1 and so on, where r is the number of the predictors or independent features. The output variable is often denoted with y and takes the values 0 or 1. So, when do we need classification? So, ayan. So, you can apply classification in many fields of science and technology. For example, text classification algorithms are used to separate legitimate and negative spam emails, as well as image recognition tasks are often represented as classification problems. So, other examples involve medical applications, biological classification, credit scoring, and more. Image recognition tasks are often represented as classification problems. For example, you might ask if an image is depicting a human face or not, or if it is a mouse or an elephant, or which digit from 0 to 9 it represents, and so on.